This video helps students understand how LTI system respond to sinusoidal inputs in the exam conditions. In this problem, the input signal in the time domain is given and the impulse response of the system is also provided. We are asked to find the output signal in the time domain. To solve this problem, we first need to recall a few important points. The first point is that the Fourier transform of sine omega n is a rectangular pulse in the frequency domain, extending from minus omega to plus omega with an amplitude of 1. The second point is that if the input of an LTI system is of the form a cosine or sine omega 0 n plus theta, then the output will also be a cosine or sine signal with the same frequency. However, the amplitude will be multiplied by the magnitude of h and the phase will be equal to the original phase plus the phase of h, as shown. Now, let's move on to solving the problem. First, we find the frequency response of the system. The frequency response consists of two parts. The first part is a rectangular pulse from minus p over 6 to p over 6 with amplitude 1. The second part is a rectangular pulse from minus p over 2 to p over 2, also with amplitude 1. By adding these two pulses together, we obtain the overall frequency response. If we analyze the sum in the interval from minus p to minus p over 2, both pulses are 0. In the interval from minus p over 2 to minus p over 6, one pulse is 1 and the other is 0. In the interval from p over 6 to p over 2, the situation is the same. And in the interval from minus p over 6 to 0, both pulses are 1, so their sum is 2. As a result, h e to the power j omega is obtained as shown in the figure. Next, we analyze the input signal. The first part of the input is sine p over 8n. The signal corresponds to two unit impulses in the frequency domain, located at plus and minus p over 8. According to the second point, at these frequencies, the magnitude of h is equal to 2 and the phase is equal to 0. Therefore, the output corresponding to this part of the input, which we call y1n, is 2 sine p over 8n. The second part of the input is minus 2 cosine p over 4n. At the frequency p over 4, the magnitude of h is equal to 1 and the phase is again 0. Therefore, the output corresponding to this part of the input is exactly the same as the input, which is minus 2 cosine p over 4n. Finally, by adding these two output components together, The overall output signal Yn is obtained as shown. In this video, we solve an exam-oriented problem on discrete-time LTI systems. If you found this problem useful, you can check out the other related videos on this channel as well.